Hi students, I would like to discuss velocity time graph. Similar to the distance time graph, we can plot velocity versus time graph. So in the velocity and the time graph, we will take time always on x-axis and velocity on y-axis. So by using velocity versus time graph, so this is the NCERT figure is given at here. So the time is always on x-axis. The time is always on x-axis. So this is the time. So this you can take as x-axis and velocity on y-axis. So in this case, we need to discuss about three cases. So in that first case, let me see the first case. When object is moving with uniform velocity. So this is the first case we need to discuss in the velocity versus time graph. When object is moving with uniform velocity. First of all, what is meaning of uniform velocity? Uniform velocity means object always travels with the same velocity. So here we can see from the graph, when time equal to 1 hour, the object velocity, here it is 40 km per hour. Now time became 2 hours, the object velocity do not change, it is maintaining 40 km per hour. And when time equal to 4 hours, still the object velocity remains same, means the object velocity not at all changing. If the object velocity is not changing, so then that velocity we call as uniform velocity. So for the uniform velocity moving object, the velocity versus time graph will be a straight line. So this straight line tells about from the graph the information. I can say the object is moving with uniform velocity. So this is the information I can get from this velocity versus time graph, moving with uniform velocity. What else we can calculate from this graph? So from this graph we can calculate the displacement. First we can calculate the displacement of object. It means with this velocity and within this time, you can select any of the time how much the object is displaced. So to find the displacement, we need to calculate the area of the velocity time graph. So this is the key point in this graph. From velocity time graph, the area of the velocity time graphs is equal to the magnitude of the displacement. So let us see how it is. First let me clear this out. It's a simple formula which we already know that. So that is, so what is the velocity formula? You will write velocity equal to displacement upon time. So you need to find displacement. So displacement equal to velocity times time. So this we can get it. Okay, now what is the area of a, suppose here you can see this is ABCD is a square, Now what is the area of a square? Area of a square equal to side into side. So in this ABCD, If I take one side as AC, so this is the AC side, times another side we can take as a DC. This is the another side, AC times DC. Now what is the DC at here? DC is nothing but a time. So here there is given that, so T2 minus T1. So DC is nothing but a time. And what about AC? AC is nothing but what is given on the y-axis? The y-axis is given that velocity. So in the place of AC I can write velocity, and in the place of DC what can I write? I can write time. So velocity into time. So what we can write? This is nothing but a displacement. So that's why I said that the area of velocity versus time graph, the area enclosed by velocity time graph equals to the magnitude of the displacement. So if you find velocity time graph area, so that area equals to displacement. So let us see what is uniform velocity, the object moving with uniform velocity. So by using PHET stimulation, we will observe how it looks like. Suppose a person is moving with uniform velocity 1 meter per second. So how it looks like? This is the PHET stimulation, the moving man. Right here, if I set the object person velocity 1 meter per second, and if I hit the play button, so the person is moving at there. So now here you can see he is moving. His motion, if you can clearly observe, is moving with a uniform velocity. So let us see with the slow motion again. So his velocity is not at all changing. So his velocity is not at all changing. See, he is moving with a uniform velocity. In the graph, we will represent that as a straight line. At here, it will be goes to as 1 meter per second. So let us change its velocity and see how it looks like. Suppose at here, if I give the 3 meter per second, and if I bring him to the 0 at again, now I will give to him a 3 meter per second. Let us see how his motion. Now earlier it is a 1 meter per second, now it's 3 meter per second. It means I increase the velocity. Now his motion will be fast. Now he is moving very fast, and that is moving with the uniform velocity. So his velocity is not changing any time. So if the velocity is not changing, so we will represent that in the graphical motion. So this y-axis, so this is the y-axis we can take as velocity, and this is the x-axis we can take as time. So this is the time is given in terms of seconds, and the velocity is in terms of meter per second. Now his at here in the graph it gives the 3 meter per second. The time 0 to 2 up to here we can take as a 3.5. Now this straight line, so this straight line tells about the person moving with uniform velocity. If an object moves with uniform velocity, then that object motion, so that object velocity time graph we will represent as a straight line. So one more time I would like to show you that how the motion will shown in the graph if a person or if an object moving with uniform velocity. So this time I would like to keep his velocity as 2 meter per second, and I will hit that play button, and you can observe the graphical representation. Now the graphical representation at here becomes as a straight. So this straight line represents the motion of the person is uniform. See the second case. The second case is when an object is moving with uniform acceleration. When object is moving with uniform acceleration, what the velocity time graph shape represents. So to do this case, I would like to solve one NCERT example. Imagine a situation. You want to test a car speed. So you and your friend testing a car engine, and your friend is driving and you sat next to him, and your work is at here, you are recording the velocity of the car by using speedometer in the car for every 5 seconds. So you are allowed to drive in a straight road, so you can increase the speed how much you can, because you want to test the engine. So if it is straight road, so you have to move in a straight line, so we can able to know the what is the velocity of the car by the speedometer. So you are next to the driver's seat. Now you are taking notes for every 5 seconds what is the velocity of the car. So the table is given at there. If you can closely see the table, the velocity of a car at regular intervals, the time 0 second, 5 second, 10 second, 15, 20, 25, 30, and this is the velocity of the car in terms of the meter per second and in terms of the kilometer per hour. Now our task is to plot a velocity versus time graph. Velocity versus time graph. So we will plot velocity versus time graph, and we will see what is the shape of that graph. So earlier case was different, so that is object is moving with uniform velocity, but this case is the car is not moving with uniform velocity, it is moving with uniform acceleration. So you can give accelerations as much as you want. Let us plot the velocity versus time graph. Here you can see I have taken time along on x-axis and velocity on this is y-axis, and this is the details what I have. When time equal to 0 second, the corresponding velocity here I would like to represent the graph in terms of meter per second. I have taken in terms of meter per second. When time equal to 0, velocity of the car is also 0, so we can mark a point right at here. Second point, when the time equal to 5 seconds, the velocity of the car became 9 meter per second. Now bring the intersection point. So when the time equal to 5 seconds at here, so velocity write 9, so let it be somewhere at here. Now when time equal to 10 seconds, the velocity is 18 meter per second. So time equal to 10 seconds, velocity 18. So it is just below the 20. So I will mark at here 18 kilometer per second. When time equal to 15 seconds, velocity equal to 27 meter per second. When time equal to 15 second, velocity 27. So just above the 25, I can put 27 right at here. Now the next value, when the time equal to 20 second, the velocity is 36 meter per second. Time equal to 20, velocity is 36, just right above the 35. So we will mark at here. And second last point, when time equal to 25 second, velocity equal to 45 meter per second. When time equal to 25, velocity equal to 45, right at here intersection point. And the last value, when time equal to 30 second, velocity equal to 54. So 54 is just below the 55. So right at here we can put the mark. So these are the points I plotted in the graph. Now I would like to join these points along with a straight line. So if I take a straight line and I can get the shape of the graph for uniform accelerated motion. So this gives a straight line. So our case is uniform accelerated motion. Accelerated motion. Now what is the shape of the graph? The shape of the graph is a straight line. Straight line with inclined slope. Now this shape of the graph represents the object is moving with uniform acceleration. Now let us try to find out how we can find the displacement. So we know that the area of velocity time graph gives displacement. So that's the point we already learned. So the area of velocity time graph gives, you can write it here, the area of velocity time graph gives displacement. So to calculate the displacement, so let us take a task that what is the displacement of the car between 10 seconds to 25 seconds. So what is the displacement of the car between 10 seconds to 25 seconds? So for that we need to highlight that points in the graph. Where is the 10 seconds? At here it is the 10 seconds. So I can put a straight line at here. So that is the 10 seconds, correspond x-axis point, corresponding velocity. Where is the 25 seconds? I can put 25 seconds at here. So this is the 25 seconds point. Now this is the corresponding x points. Now if you can take same corresponding y-axis also, you can get the corresponding values. So at 10 seconds, the velocity of the car is 45 meter per second. At the same time, at the 25 second, the velocity of the car is 45 meter per second. Now at the 10 second, the velocity of the car is 18 meter per second. So this is the 18 meter per second. That is the two values what we got. So this value is 18 meter per second. Now to find the displacement, I need to calculate the area in between these two. So if I highlight the area of the region, so I would like to highlight with the pink color. So I can highlight that the area of this shaded region. So from there to up to still the end. So we need to find out the area of this region. Let me take big. So the area of the shaded region, if we can able to find the area of this shaded region, so that gives the value of the displacement. Yeah, let it be. Now how to find this area? By seeing this shape, so it's just like a trapezium, okay, and it's have the four sides, so I can say its names as A, B at here, and the C and the D. A, B, C, D is a trapezium. Or further, if you can able to make a cut at intersection point at here, from here to there, I can call this point as E. Now this area having two shapes, so this is the shape of a triangle and this is the shape of a square. To find the total area, so the area of A, B, C, D equal to area of triangle. What is the triangle there? So the triangle A, B, C. Area of small triangle. So the triangle name is here that is the right triangle. So let me draw a right triangle at there. Area of a right triangle. So this is the right triangle. This value B, C and E plus area of a square. So here the square is that A, B, E, D. So to find out the area ABCD, we need to find out the area of a triangle and area of a square. So what is the area of triangle formula? Half times base here I can take as a B, and height equal to CE, plus what is the area of a square? Side into side. One side you can take as an AD times another side you can take as BE. So it's a very easy to calculate the area of the graph. So if you find out that area, so that gives the area of ABCD. It gives displacement. So this is the way to calculate the displacement from the velocity time graph by plotting velocity versus time graph and by knowing these areas. So we will do certain example. So by knowing that, we can easy to understand. So this is the graphical representation for uniformly accelerated motion. So this gives to me the second case. Let us see the third case. The third case in the velocity versus time graph is a body is moving with variable acceleration. What is the meaning of variable accelerations? Just like all of a sudden increasing, again decreasing, again increasing, again decreasing. So this variable is opposite word to uniform. Uniform means remains the same. So if object is moving with uniform, we will represent just like a straight line. So this tells about uniform. What about if object is sometimes going up, again going down, again going up, again going down, going up, going down. So here you can see this is opposite to the uniform. This we can take as variable. It means it will be changes continuously. So here what is changing? Here the changing parameter is acceleration. Suppose in case of non-uniformly accelerated motion, the velocity time graph may have any shape. So if you can take the example is given at here. So the graph of non-uniformly accelerated. So this is the case you can take. So this is the velocity versus time graph. So in this session, if you can see the shape of the graph, so here up to velocity is increased, up to velocity is decreased, again increased, again decreased. So this gives any shape. So this any shape tells about the object moving with non-uniform acceleration. If an object moving with non-uniform accelerations. So this is the general case whenever we cycling or whenever we taking our vehicle. So almost all the cases are the non-uniform cases. And one more example is given at here just above. So the graph shows about the velocity versus the time graph. So this is the one. So this graph tells about the velocity is decreasing, uniformly decreasing. So this is the another case. So these three are the three different cases we discussed in the velocity versus time graph. The first case tells about when the object moves with uniform velocity. If the object is moving with uniform velocity, so this is the first case. If the object is moving with uniform velocity, if the object is moving with uniform velocity, just remember the shape of the graph. So it is just a straight line with uniform velocity which is parallel to x-axis. And the second case, when object is moving with uniform acceleration. So this is the second case we discussed, when object is moving with uniform acceleration. So in that case, the velocity time graph. So this is the shape of the velocity versus time graph. So the graph is increasing linearly. So moreover that, the third case, when the object is moving with the variable acceleration, it means object can move with any accelerations, whether increases or decreases or any kind. So now here you can see the last graph which is shown at here. So this graph tells about the object is moving with non-uniform acceleration. So in all the cases, what we can find by using velocity versus time graph. So we can find by using velocity versus time graph the area of the velocity versus time graph gives the displacement. We can find a displacement. And we also find acceleration. So this is all about the concept of velocity versus time graph.